Okay, we're here to demonstrate unique current supply. Gives you 12 volt, 24 volt and 48 volt. I just switched on the system. You can see it's running at 53.6 on the 48 side, running at 26.1, and it's running at 12.2. I've got a 5000 watt modified sine wave inverter. I've got on the 12 volt side, I've got a 3000 watt pure sine wave on the 24 volt side, and I got a 6000 watt embassy pure sine wave on the 48 volt. I'm going to be running, let me show you, on the 48 volt side, 24 volt side. There we are, 2400 watt peak grinder. On the 12 volt side, 710 watt drilling machine, and on the 24 volt side, 48 volt side, we're looking at a heat gun, 2000 watt. Now I'll put all three of these on at the same time, and we could look at how the system reacts to it. Now if we put it on, we'll first put on the grinder. We'll start up, look at my voltage on the 24 volt. Start up current, drops it down, then it goes. And goes for the drilling machine. Drilling machine running on the 12 volt side, come down to 11.4. On the heat gun is on. Takes the voltage down to 49.8. Remember now, it's everything running at once. You'll see it will go down 23, 22.8, 11. However, the system will maintain it all the time. Doesn't go lower than what it is. It's running at full load, 3 inverters at exact same time. Now, if we stop the equipment, you'll see there the system recovers and immediately starts pushing the voltage back. Now what I'm going to do, that's the one process on load shedding. The system will maintain the voltage, and when it stops the load, it would actually increase. Now what I'll do is I'll plug it into the main supply, the grid, and then I'll show you the performance of the system. You see the numbers? See the numbers? There we are, unique current supply. Now look at the numbers when I switch it on the grid. Let me just quickly show you the numbers before the time. The minute I switch on the system, look how it recovers the voltage. There we are. Now when you run from the grid into the unique current supply system, it only uses 0.6 kilowatt per hour, and you can draw whatever kilowatts you have per hour, but you're only going to be paying 0.6 kilowatt per hour. So you're going to have a saving on your electricity bill of anything from 50 to 90%. Doesn't need any solar panels, doesn't need any additional batteries. Gives you a power saving, and it charges itself while it's running. And if there's load shedding, the system just switches over and runs itself up to 8 hours. That's what you're seeing here. You're seeing 3 inverters, 48 volt, 24 volt, and a 5000 volt modified running at once. Now, let me show you once it's on the grid. We're going to do the exact same exercise. This time we're just getting the full power into the system so it will keep on charging. Now have a look specifically at these 2 cages. Okay. All the machines switched on, maintaining it on the 48 volt side, 53.9, 54, and 24 volt side, 24.5, 24.9, and the 12 volt side, 11.1. So the system literally maintains the power, just drops a bit of voltage. And I want you to check the minute we take the load off, put off. Look at how the system recovers immediately. In other words, the load is off, but the system's running. Now, anybody will tell you on solar, you run elements, which I've got a heat gun and a 2400 watt grinder plus a 710 watt drill, running all 3 inverters, 12 volt, 24 and 48 volt off one system. It would have popped long time ago. There's no solar power involved here. It's all on AGM 100 amp normal gel batteries. Bank of 4 batteries, 48 volt. Thank you. That is what we do at Unique Current Supply, which is a division of Unique Containers. Thank you. Bye.